Welcome everyone to 96Boards Open Hours, and today sponsored by Lenaro, of course. We are joined by a very special guest, Barry Byford. We will introduce him in just a minute, but as always, we dive right into some announcements, as well as a look back at last week's episode. So we'll go with last week's episode first. Last week's episode, we met with Riccardo Salvetti. It was a very fun episode. We talked about home brewing. So for those of you who enjoy beer, I suggest checking it out. I'm going to post last week's video here. This was episode 45 in the chat. So for those of you who are interested in checking it out, episode 45, Open Hours, paste. That's last week's episode. Riccardo Salvetti, home automation, right? Not home automation, but home brew automation. And so he used a high keyboard. He used a Dragonboard 410C. In both cases, he set it up through BrewPi and had a variety of brews that he was making, monitoring their temperatures, all sorts of really cool stuff. After that, we did post a blog, and actually, I'm going to count on Christine to post that on the chat. So we have a 96Boards blog that went out around this as well with all of the instructions. It kind of outlines what we did last week as well. Great. Announcements. So today is going to be the first day that we officially gamify or make our first attempt at gamifying the community, right? So for those of you who aren't familiar with gamification, you play a video game and you're awarded various things, right? Non-tangible objects such as portraits, frames, items for your little avatar character, whatever, so be it. We're going to be doing this around community points. So we want to see you participating not only in open hours, we want to see you participating in blog comments. We want to see you participating on the forums. Daniel Thompson's going to keep an eye out for people. And every time you attend open hours, I will generate a open hours code. I'll give you the code along with a link to our Google form, and you just fill out the Google form. You get your community points for that day, and hopefully by the end of all of this, you end up with free 96Boards goodies, swag, Lenaro stuff, and maybe even been talked about, but possibly a badge to our next Lenaro Connect, which happens to be in Burlingame area, San Jose area, up in a Bay Area, I guess, right around there, September. Okay, I think that's enough with the announcements. I will give out the link to the Google form, and I will give out the code at the end of the episode. So please stay tuned. For the meantime, Mr. Byford, Barry, how are you doing today?
I'm very well, thank you. Very well indeed, yes.
Great.
Got a beautiful day over here in England.
Yeah, so you're coming to us from England then. That's pretty crazy. It's 8-hour difference from me, I think, in the future.
Yep. Well, it might be slightly different because we've had the hour change already. We're on summertime.
Oh, okay, cool. Well, so you've been attending open hours, I think, for quite a while now. You've been coming on. I swear I've seen you here for at least the last few months. And we've talked about several things that you've been up to. You've done some mezzanine projects. We've talked about Bluetooth. But diving into this whole episode about something you've been working on, I like to usually start off with introductions to yourself. So would you mind maybe taking a minute, telling us, some personal details about yourself? Uh-oh.
Yep. So I'm going to share my screen. Be afraid. And if this works.
So you just cut out there for a second.
Okay. Am I back?
You're back. You're back.
You see my screen?
Yeah.
So I'm sort of introduced myself in about 5 tabs on the browser here. So I guess most of my working life I've been around making chips and electronic design automation and that kind of stuff. But back at the tail end of 2013, over in Cambridge, they were launching this new STEM, which is science, technology, engineering, and maths experience called Go for Set, and it was really to try and bring the next generation of students along and giving up one lunch hour a week for 10 weeks. So I said yes, I'd go along and do it. And I think I ended up learning more than the students, because they taught me about Arduinos and Raspberry Pis and all of these things, and we built some projects, and it seems that the two things that school children care most about is getting registration done with less hassle and queues for lunch. And so they wanted to do stuff with Bluetooth. So and we couldn't do it. It seemed quite difficult at the time. But after I'd finished with them, I started experimenting, because the organisation that had arranged this, they also did a STEM fair in the summer. So I sort of did this prototype of GPS, and we would go out, and the idea was measure the school field or whatever. And at this point, I learned that building one was within my budget. Building a whole for a school was a little bit more expensive. So we got some sponsorship for that. But the problem with GPS is it doesn't work indoors. And taking kids outside at big STEM fairs, where you have to try and control them out in the car park, or when it's raining, was really difficult. So I still kept thinking about Bluetooth, and had started doing a workshop with Bluetooth beacons. And it was an absolute terrible workshop that no one really liked, especially compared to the GPS one, which was very popular, even though it had some logistical issues. But what did come out of that was I collaborated with a couple of other people, and they had this idea in Cambridge War of Ideas, and they had won this installation where they had access to one of the college chapels, and their idea was that people walked around very calmly, very slowly, and they would hear poetry and music as they went around, but they had no way of doing it. So I used some beacons and a single board computer with headphones attached, and you can see people here wandering around the chapel and doing it. So that was very good. At another year, hopefully there's some equipment here that people are familiar with. So we used the 96Boards with the linker kit, and we did some GPIO experiments for people, which Qualcomm sponsored us for the kit. So very good. But then sort of that leads me on to still wanting to do Bluetooth, and I guess that sort of links me into sort of today's talk and demo.
That's really cool. And so, how old were these kids? I have two things I wanted to talk about. So, how old were the kids that you were talking about with the STEM education course? So, the junior high school?
Ages sort of 12 to 13.
Gotcha. Okay. I was doing something similar to that. What was it? It's an outdoor laboratory here in San Diego. They call it Earth Lab. And so it's about 4 acres big. And what they did is they gave all these little pieces, or like they assigned projects throughout the whole piece of land, and it's right next to a middle school. And so the students, so first of all, each little piece of this land was kind of designated for a particular project, and then universities could come in and basically make that project come to life, right? And then the students in that whole area, which is kind of, like an underserved area of San Diego, can come in and experience an outdoor science laboratory. And the whole thing is, like pitching the STEM education: science, technology, engineering, mathematics. So that's really cool. That story is really cool. The other thing I wanted to share here, which was something he touched on, Barry touched on at the very end, is that project he did around the GPIOs. And so here's a link to his efforts. If you do have a Link Sprite kit, an Arrow Link Sprite kit, you can see that is yours, right, Barry? Yeah. Okay. Contributor,
yeah.
Barry Byford. Yeah, that's yours. So there's all sorts of really cool stuff in there about the Link Sprite Aero mezzanine. So for those of you who are interested, you can check that out. There's lots of sample code and fun things to play around with there. Great. So today we're here to talk about Project Big Button. What do you got to tell us about Project Big Button?
Well, so I guess I've got my my Dragon Board 410C here, and I've been playing around with so on Linux. So my interest is Linux and Python. So I've been playing around trying to connect that up to Bluetooth low energy devices, and also a number of them. So using the Dragon Board as kind of a hub to connect to different things. So I ultimately want to create a schools workshop from this, but initially I wanted to do sort of a show and tell to go out and be able to talk to people about Bluetooth. So I was looking around for ideas, and at one of the events in Cambridge, somebody had done this like whack-a-mole thing with Wi-Fi, and I thought, oh, that would be better with Bluetooth. And so I found these large arcade buttons that are intended for arcade machines. So I bought four of them, and I thought that would be great. So inside you can see there's some connections up there, and they're done with crimps because they're intended for arcade machines. But the lights in them are 12 volts, and I haven't got 12 volts. I've got 6 volts, but I found this motor driver board that worked quite well with the Microbit. So the Bluetooth device that I'm using is the Microbit. So for those of you not familiar, the BBC, the British Broadcasting Company, has a charter to educate and inform people as well as entertain them. And I guess back in the day, a lot of people that are in our industry that are old men grew up with the BBC Micro, which was one of the first home computers in the UK. And so the BBC wanted to reproduce that, and they thought Internet of Things is the current thing. So they came up with this little microcontroller. But you can program it very easily with a blocks-based programming language right up to the embed platform. Zephyr run on it. People have ported Zephyr to it and all kinds of stuff. And it's got Bluetooth on there. So that was kind of the core of my Bluetooth device. And then that just sits in there and connects up with wires to the buttons and the light in the button.
So essentially, I mean, what we're looking at is a whack-a-mole game. That's kind of what you've made.
Right. So yeah, let me share my screen, and we can start showing. So the hope is that hardware can be used for various different things, and then on the Dragon Board we're do Python programs to try and get different things. So this is the first one that I did. So as I fire this up, you should see. That's always good, isn't it? Did I forget to switch one on?
It's the curse of the demo gods.
Yeah.
Always. Yeah. So I remember I was talking with Barry about this the other day. It's very cool. This is a whack-a-mole game, right? But
yeah.
I mean, the underlying principles or the underlying code that's making all of this stuff happen can be used for an endless number of applications, right? So I mean, essentially, this is a nice use case foundation project that can allow people to branch out in so many different ways. I'm, pretty exciting. There you go. Everything lit up.
There we go. We got 4 Cs now.
So I have a question actually. Can everyone see that? Is that visible? What Barry just showed? Yeah. Okay. Cool.
I can only see the main screen. I can't see the buttons being pressed.
Oh, so Barry, maybe we could, how we practiced the other day, maybe you could throw up the, maybe that'll, there you go. Hey.
I think it's my fault. I threw the slider to the wrong position. So my slider has been stuck on show everybody. There's the Bluetooth slider at the bottom that allows you to choose between your cap and the screen share. I had it set for the screen share.
Oh, well, he has his photo booth up now, so we're good.
Cool.
So I did this fairly simple GUI here, and as Robert was saying, it's a whack-a-mole style game. So you get 20 seconds to whack as many moles as you can, or in this case, colored buttons. So we hit start. It tells us what color button it is, and that's lit up over here. So we whack that, and red, and so yellow, and blue. And you can see I've just got some debug output kind of coming out of the bottom. So I've finished, and I've scored 5 points. So that.
What is your high score? Because I feel like every time I've seen you play this game, you get 5 or 6 points.
So I have a challenge against my 2 kids, and we spread them out around the living room to make it a bit more challenging. And because that's having them all right next to one another doesn't really take advantage of the wireless capability. So we have them spread out around the living room, and our best score is about 14 in 20 seconds. Nice. But I'm normally sort of begging for mercy by the end. I want to give up before my kids do.
So I might have missed this, but what's powering each one of those boxes? I mean, is there just a little power supply, battery in there, and how long?
Yeah. So there's 4 AA batteries in there, and I suspect that the LED on top is consuming more than the actual electronics, and that's really why we need the big button. I've got one here that just runs off a coin cell, and that's been running for months off that coin cell, on and off.
Cool.
So, and the idea is that we'll be able to create different games, like from this.
Yeah, that's exactly what I was going to ask. Is there any intelligence in the boxes, or are they just sending a message to the host saying I've been pressed?
The software running on there is just a predefined image that is available for the Mircobit that just exposes all the Bluetooth services. So if we maybe bring this up, so there is a predefined service for temperature and for buttons and for the GPIO pins as well. So all the intelligence is on the Dragon board. So I just say, turn on pin 8, I think it is, for the lights, and that turns that off, and I get notifications sent when the button's been pressed. So the box is just done, and we could use the same thing for everything. Likewise, I could have some of the decision making on there if I wanted, but the idea is that it's just the same configuration for all.
So are you going to walk us through? Oh, sorry. Go ahead, Daniel.
Sorry, Robert. Go on. It's all right. You run the show.
No, please, take it away.
I was going to say it'd be really great. So you can reconfigure it to be a quiz system just by run something on the Dragon board, and then you can send it out to all the kids in teams of 4 and give them a quiz about how it all works. It'd be awesome.
Exactly.
I was thinking Simon. You know, like the memory game.
Yeah.
No, that's cool. So you were going to walk us through a little bit of the code, right? I mean, I know you kind of talked about the hardware inside of it, or you ran the demo and everything, but were you going to break this down for us?
Yep. So so rather than walk through the exact code within, I don't need this anymore. That we use for the button press. I thought I'd just spend some time talking generally about Bluesy, which is the Bluetooth stack on Linux, and sort of how I go about getting this to run, and hopefully this interactive session will help. So the first thing is Bluesy comes with a command line tool called Bluetooth Control, and if I type help, we'll just start a client up that's sort of command line and text based. So, for instance, I can say show, and it'll tell me about the controller inside of the Dragon board. So I could power it off. So if I do show, we can see now that the powered is no, and power on, and I've turned it back on. I could do my scanning from here, and after I did a scan, I would get a list of devices that it had found. So I'm going to just fire up this other device here, and so if I wanted to connect to that device, I could just say its address after saying connect, and hopefully, yep, we see the C that has arrived on the microbit here. Say we're connected. We've also got a list of information that it's found. So the BLE services on here. So I don't know the level of experience of people on the call with Bluetooth, but you basically build up a path from the adapter through the remote device. If we're talking Bluetooth low energy, then it's services, which have grouped together characteristics, which often have descriptors within them. So what Bluesy does, or this particular interface, is it uses dbus, which gives you an object path like that. So that's to this characteristic. And this is the UUID, which is what you would typically think in if you were doing Bluetooth low energy. So what we can do is we can take this UUID and we'll just do a bit of a research. So if I put that in there, we can see that this is the temperature characteristic. So if I wanted to read the temperature of the, I first of all select the attribute and then put in the dbus path, and we have that there. So if I now do read, we get a hex value of 18. So for those that are good, is that about 24 degrees? It's reporting back. I want somebody to confirm my hex knowledge.
You're saying 18 in hex?
Yeah.
Yes, that's right. That's 24.
Thank you. So so I can do a read again, and well, what I can also do is get it to notify me, and the Bluetooth profile that's in there will update that value on a time basis. I got to say notify on. So now we're getting updates on that. So hopefully, if I use that, this probably isn't going to work because it's turned out to be a really hot day. Oh, there you go. It's slowly creeping up. So you can see that it's slowly creeping up. So I can turn that off, and that stops notifications, but I can still do a read if I want. And then if I want to disconnect, that would then disconnect me from the device, and we can see we have a D on there. So that's just a command line interface to BlueZ, and typically when I start looking at a new device, I'll explore it in this kind of way, just to get a feel for what's on the device. I can also do things like info on the device like that, and tell me what things it's advertising, etc. So that was BlueZ in the command line tool. Is there any questions around that?
So I saw someone ask a question, which I think might have gotten answered by Daniel, but are there any speakers or buzzers inside those boxes?
There isn't anything in there, no.
Yeah.
So I do. I do have a robot add-on for the Microbit, which does have a buzzer and stuff on it. But anyway, that's a different story.
Yeah. So I was gonna add here, and it looks like someone did ask a question, but just so everyone knows, this project has already been uploaded to the Qualcomm Developer Network, and you can find it right here. Actually, I'll just go project big button. I like writing the big in all caps. I don't know if that's kind of like what you do, Barry, but project big button on Qualcomm Developer Network. There you have access to his bill of materials, all the instructions it takes to literally recreate what he's showing us right now, right? So I would actually encourage anyone who does this to take what Barry has done and make something else. Like, I think that would be really cool to see other derivations of this project. I mean, that's the beauty of open source, right? You're kind of messing around and creating your own thing with what already exists. So we got a question here.
That does remind me of one thing. So the version of BlueZ isn't the default for Jesse. This is up at 5.43 to get the Bluetooth low energy support in production thing. Now the next version of Debian is Stretch, and I believe that 5.43 has already been agreed that that's what will be in Debian Stretch. I don't know when that's coming to the Dragon board, but there's also links to instructions on how to up-rev BlueZ. But yeah, that's a point I forgot to note.
Nice.
I believe the Dragon board pre-release images are already using Stretch. I can double check, but I think they are.
You're talking about in the snapshots?
Yeah, the snapshot images for DB410C are already switched to Stretch, I believe.
Okay.
Okay, then that's very good news. I should probably switch to them.
So we got a question from someone on here, and sometimes the chat doesn't resemble what your actual user or handle is here, but one question says, is there any noticeable delay? Example, if you use it for a quiz buzzer to figure out who pressed his or her button first, any idea about timings delays? Example, would people think, hey, I pressed first, but the system did not react fast enough? Actually, yes, because since it is, I guess, Bluetooth communication, right? What if what if the interference from one box to the host is different than the interference from another box to the host? In reality, one person hit it first.
I think that's a problem. You would probably have to do some kind of sync. So I believe that you have access to seconds since it's been switched on, but some maybe want to try and sync it if so it was actually sending the time that it was pressed. I think if you wanted it that accurate, I would hope that yeah, it wouldn't be that bad, but
yeah, you can
it's always
actually
possible.
broadcast. Maybe you can broadcast the time on the.
Yeah, so broadcasting the time, or someone put here that you could sync using a heartbeat, NTP Linux
Yeah.
network time sent back and forth.
Yeah, and there is a BLE profile around time and sending time, so it could be done, but I would hope there isn't too much difference between them, and it'd probably be good for school kids to do. But if you were,
oh no, go ahead, keep going. Sorry.
well, I was going to say if you're doing $1 million game show, you might want to put the extra effort in, but for school kids, I think it'd probably be good enough.
Yeah, so Rajan, you just spoke up right now. I heard you were playing around with some of these big buttons.
Yeah, we did, but I kind of ran into a couple of issues that I talked to Barry as well. So yeah, hopefully we'll get those things sorted out.
Cool. So, does anyone else have any more questions? Barry, were you going to run on with some more stuff? You got some more stuff?
Yeah.
To show us?
So I was then going to go off and show in Python, you know, how to kind of interact with the device as well.
Let's do it.
Okay. So it's probably worth just bringing up the browser at this point. You'll see that this is the Bluesy documentation that there are links to from the article I wrote up, and there's a few bits of key information in here. So it tells you the dbus service that this is for the interface, and then the object path, and hopefully that looks familiar with what we were looking at earlier. And then this is the services, so there's just properties, but for the characteristics, there's a read method and a write method, and this is pretty well documented, this piece of it. So so the way to access dbus is there's a very good library called PyDbus import. So there's two buses in dbus. There's a system one for system-wide stuff, and then there's a session one for session-wide stuff. So the Bluetooth is all on the system bus, and so we import that, and then we're just initialize that like so. So that's initialized our thing. Now, as you saw as I was doing the command line client, the dbus and BLE, you know, have different references to the same thing. So BLE is UUIDs, dbus is the object paths, but there is a dbus manager. So dbus get. So remember we had our service, so we're going to get an object, the manager object, and we're interested in the manager object for the BlueZ, and that lives at the root object path. So we can get that, and then we can introspect it and get everything knows about, which is quite a lot. If we just go back here, so I can remember what my device handle was. So if I look in here for this device, we can see that we found our address here, and if we follow this back, the way this is formatted, it starts with the dbus object path, and then it tells you all the things on there. So if we wanted to connect to that device, I just need to move this up a bit. What we can do, I forgot to copy and paste that object path. So what we can do is we say our microbit object. So we're going to get this from dbus, and it's the BlueZ service that we're interested in, and this is the dbus object that we're interested in. So now we have a Python object that is a proxy of our dbus. So if we want to connect, we just say connect ubit microbit, and you can see we've got the C here. Our client here has also said that we've connected. So now we have it connected, and we can now, for instance, I think it's name. So we can get the proposor in our thing over here. So our device properties, I go down. So you've got things like address, name, whether it's paired or connected. So if I did ubit.connected, so it says it's true. So that's how we take the dbus information, relate it back to our BLE information, and then we connect. Any questions on that?
I think I'm just going to need to play around with it.
Yeah.
Yeah. So also, I was looking here at the bill of materials for a microbit. I mean, I guess it kind of depends on what I want to build, and if I want to build something similar to yours. But what am I looking at that I absolutely need for the microbit? So I need obviously the piece itself, right, the chip. But then it looks like a USB to micro USB. That's what I've never had one. I've never played with one, right? So micro USB to USB cable.
Yep. To program it up. Yep. And
then powering it is just one of those little 2-prong power ground cables with the right connector?
Well, so it will be powered up over that USB connection. So you could just get started with that. And there's two buttons on the front of the microbit, and they're broken out to this edge connector. And actually, my big button is actually connected to the same as these little buttons. So okay. Just for people to test and play around, you could do that. And there's lots of interesting sensors on the microbit. By default, there's a magnetometer, accelerometer. There's the temperature. There's the buttons. So there's quite a few.
And these holes at the bottom of the microbit where it says ground 3 volts 0, 1, and 2. I mean, I mean, that's essentially like, it seems like you could short it out pretty easily by accident. No?
Everything's possible, but you know, the last 6 weeks I've been going in and running an after school club in a local school with these microbits, and we haven't had any of them damaged by these 9-year-olds. So and we've been hooking up speakers. So these holes take banana plugs in them. So we've been connecting speakers up, and they've been generating sound through PWM signals, etc. So,
Awesome.
so yeah.
Awesome.
So I was just gonna show how to write some stuff to the LEDs, to the little screen, if people are interested.
Oh yeah, absolutely.
Okay. So so I'm just gonna import tools. So this file I've done to help me do the lookup and some other stuff.
Barry,
So if we, yep, sorry.
would you mind just bringing your command line, your Python command line, up and to the right a little bit? Yeah, right about there. That'll be good.
Okay.
Yeah, thanks.
So so if we go back here and we search, so I know there's an LED service. Oh, it's gone back to the top of the file. So we've got this LED service. So I'm going to struggle to, so this might go off your screen a little bit, but so so I'm going to create this text object, and what I'm going to do is dbus get. So it's the Bluetooth service or Bluesy service I'm interested in, but now I'm just going to use get dbus path just to make life a little easier for myself. And it takes 3 arguments, which is my device, my service UUID, and finally the characteristic. So that's to control. So this one is just for sending text messages. So up to 20 characters. So now we have that text object. So now I can write value, and who knows any good UTF-8 characters? So I think 63, 64, 65. So there's 3. So this is just UTF-8. So so what have I done? 63 is a question mark. 64 is a at sign and A, capital A. So I'm sending that. Just a function of write value is you send some empty options to it. But now when I hit write, you should see that was quite quick, wasn't it? So it scrolled across. Let me redo that with a longer message. So I've actually got a helper function for this. So hello world. So now we should see hello world is scrolling across. So we sent it. So I don't know if there's any questions on that. We can obviously read values with this. We can switch on notifications. And if we're doing that, then we've got to set up an event loop. But again, that's pretty straightforward. I can show it, but I'm kind of conscious of the time. So if there's any questions.
No, that was very cool. I mean, this has all been very informative. I don't know. I would suggest people speak up now if you have questions. You know, I was going to ask also, if anyone has questions, speak up. But Barry, maybe you wouldn't mind coming back next week just in case people develop questions as well throughout the week if they try your instruction set.
I'll say yes.
Yeah. Cool. So did anyone have any questions for Barry? There were a couple things I wanted to talk about after we get everyone's questions answered. So what do we got? Nothing? Okay.
Yeah, so Barry, I've got a question.
Okay, please. Ross, welcome.
Okay, yep.
Hi. Yeah, so Barry, I'm a little confused what you've actually got in the boxes there. You know, in the YouTube video, it looks like you're plugging the microbit into something, and it's not clear what you're plugging that into. Could you explain that?
Yeah, so this is a hardware question. Let me stop sharing my screen. That's probably a sensible thing to do at this point. So I tried building my own sort of board, but I found a company called Kitronic. I don't know whether you can see.
Yeah.
There you go. So they had built this driver board for robots. So it just takes the lower voltage from the microbit and sort of ups the voltage that actually drives the motors. But instead of driving motors, I'm driving the LED, and then the button, the connector switch goes down, and then you're right. There's this edge connector where the microbit plugs in.
So so that's a board specifically for the microbit, and the microbit edge just plugs into that connector.
Yes.
Great. Thanks, Barry.
You're welcome.
Barry, I have a question.
Yes.
Barry, do you hear me? Okay. May I say that you are using just a BLE technology, but not the beacon, really? Is that correct?
That's correct,
yes. Yeah, okay, because you are using the services and characteristics. Usually the beacon is just emitting and just telling you where you are or things like that. And you can use the iBeacon, the alt beacon, or the Eddystone. But when you use the BLE technology, as you do a connect as well, so we may say you are just using the BLE technology on is plenty very well done on BLE technology, but not beacon. Is that correct?
So yes, this is full BLE connection with characteristics and services. My previous project where I did the installation, that was just beacons and I wasn't connecting. You're correct.
Oh, okay, thank you. Well, because sometimes I'm confused myself. I'm working on this technology, but the beacon technology is very confused because you have to filter things. It's quite better to use the BLE as simple as it is, and it gives you so much opportunities as well, as the beacon does not. So thank you, Barry, anyway. So.
Yeah, I guess the advantage of beacons is that they're connectionless. So, you can get information from them without people having to connect to them.
Cool. Let's see. So there was a list of questions from Omar here. Let me see. He looks like he's talking more so about Ubuntu Core. So I just want to let you know, Omar, that I have pinged someone from Ubuntu Core, from Snappy, and he is going to join the call in just a minute to help answer all of those things, hopefully, right? So if you want to just stick around, don't leave, he'll join the call. We can get those answered. Does anyone have any more questions for Barry? No? Great, good. Let me see, something popped up here. I don't have access to Google Form. Yeah, I'm not sure why you wouldn't have access, so I shared the link right here. It should be set to public. Oh, there, that's why. There, okay, so now you should have access to the Google Form. I think I just changed the permissions to be for everyone now. Limit one response. Let me change that too. Okay, limit one response. Someone says he has got any. Do you have any stories on your after-school microcontroller projects? So, I mean, has anyone come to you with? Have you had any students with some fun success stories or stuff that they've done around your after-school projects, Mr. Barry?
Well, the younger ones, they're 9 years old. We're just kind of getting them into it. The first half of the lesson, we kind of teach them some structured stuff. So like we taught them how to play music through a speaker attached to the microbit, and then they went off and created their own tunes and stuff. We've had them playing games, and they added scores to it. So we were doing a reaction game, 2-player reaction game, because it's got 2 buttons on there, and they added scores to it. So, you know, we only get an hour with them. It's fairly simplistic stuff, but yeah, they're doing good stuff.
Cool. So let me see what else we got here. Someone else? Okay, thank you. All right. So just because we are kind of running short on time, and I do want to address a few other things that I have on the line, I want to thank you very much, Barry, for coming on here. 1 second, real quick. Form opened, but the fields do not seem editable. So I did receive one response. I've received 5 responses so far. It looks like people are able to go in there. I'm not sure why you're having issues though, Tim. But we'll talk about it in just a second. So Barry, once again, thank you so much for joining us. We hope to see you again next week. If people do try your instruction set and run into any issues, then maybe we can bring that forward next week. Did you have anything else you wanted to add before we close this out and get the other things issued? Good?
No, thank you very much. Yeah, I'm good.
Excellent. So please expect a nicely worded blog to be released tomorrow around this. We'll talk about what was discussed today in this episode. We'll also provide many links to the Qualcomm Developer Network for you to access the instructions that Barry has so nicely made for us to recreate everything he showed us today. So on top of that, while Barry was talking towards the end, I just wanted to add here that I did share the Google form. So one more time, I'll provide that link to the Google form. For those of you who go in there, please enter the OpenHours code, which is open. I think I put open 0001. This form will be open only about half an hour after I close this session out, and then I will turn the form off. This is for your ability to earn community points. It's a new initiative that we're doing. We're trying this out. So, I mean, Chauvin's not in here right now. He's usually the guy who's running this, but we'll see how this works out. And if we have to kind of adapt and change things up to be able to log all of this later, we'll do that. But hopefully we have this leaderboard and people can start earning points and exchange them in for free 96Boards stuff and swag, and hopefully eventually badges to our Connect events. We'll see. Great. So I know that we had several questions. So I have 3 things that I want to address before we close this out. One of which is this list of questions that was given to us by Omar and Kyle. I think I saw you join. Are you here?
Yeah, I'm here.
Okay, great. So Omar, please meet Kyle Fazari. He works on the Ubuntu core team, doing a lot of stuff. Actually, one of the questions I noticed talking about ROS. We do have several videos that Kyle was in talking about that, but did you get that list of questions, Kyle, that I shared?
I did, yeah. You want me to just go through them one by one?
If you wouldn't mind, that would be great.
I would love to.
If you wouldn't mind saying the question too, so that we can get it recorded.
Awesome. All right, so the first question I've got here is it possible to make Ubuntu core persistent in the flash memory? Every time I move the dip switch back to its original position, the board boots into Android. So So the Dragon board has a built-in flash memory, right? And then you have the SD card. So I'm assuming you have Android on the built-in flash. Right now, Ubuntu Core only works on the SD card. Ogra was in he was in one of the OpenHours. I don't remember which one. If you could figure that out, Robert, that would probably be helpful. Where he talked about why that is the case, and that he eventually would like to make it so that you could flash it to the internal memory. But right now, that's not possible. The second question is, which Ubuntu version is that right now? Is it 16.04? So yes, it is. There are, if you look at the release cadence for Ubuntu, you've got LTS releases, right, that are supported for 5 years, and then 3 development releases in between each LTS. So 16.04 was our most recent LTS. Ubuntu Core is only based on LTSs. So we have Ubuntu 16, which is based on 16.04, excuse me, Ubuntu Core 16, which is based on Ubuntu 16.04. And then we'll have Ubuntu 18, which is based on 18.04 when we get to the next LTS. So yes, it is based on 16.04, but it's a little bit different, right? Because Ubuntu Core is based on snaps, not debs. So it doesn't, you don't have apt, it looks a little bit different, even though it is based on the same rootfs. Third question, under which circumstances should I craft my own version of Ubuntu Core? Actually, that's an excellent question, because and it dovetails nicely with your fourth question. So actually, I'm gonna tackle both of those at the same time. The fourth question is, I'm planning on using ROS on top of Ubuntu. Is it the only way, or is the only way to do that with snaps? So let me look at question 4 first. If you're just looking at Ubuntu, no, you can use ROS just like they document in their wiki on classic Ubuntu. That's with devs using their repository. But if you want to use Ubuntu Core, yes, you have to use snaps. Why would you choose the two? Well, Ubuntu Core gives you some, because it's snap-based. If you look at some of the OpenHours sessions we did before, we talked about that, but it gives you some advantages over debs, like rollback capability or atomic and automatic updates, etc. I won't go over that again here because I know we're short on time. So if you're using Ubuntu Core, then under which circumstance would you want to craft your own version, like make your own image? And that's actually an excellent question. So it really comes down to, when you're ready to ship something, you need a factory process that has everything pre-installed and ready to go in one image that you can just flash in the factory, right? If you're using classic Ubuntu, how are you going to do that, right? You can like precede an ISO, right? That's not very much fun to maintain. You can do it by hand. You can use Chef or those sort of automation tools. With Ubuntu Core, you use a tool called Ubuntu Image that allows you to just say, hey, I want this gadget snap, this kernel snap, and these extra snaps on top. And you have an image that you can just send to the factory. Another example of why you might want to do that is if you need to expose some hardware that's on the device that the reference gadget doesn't expose for you. So for example, I'm working on I just finished a blog series. It's not published yet, but keep an eye out. That talks about taking a ROS prototype to production with Ubuntu Core. So basically exactly what you're asking here. And one of the things I had to do, one of the things I cover is creating a custom gadget so that you can expose the robotic system in a confined manner rather than having to run unconfined. So keep an eye out for that. And I made sure that tutorial was targeted at both the Intel NUC and the Dragon board. So that'll be interesting for you. Last question. If I'm not looking at the chat, if anything pops up, please let me know. Last question was, what's the difference between Lenaro's Linux-based image and Ubuntu Core? Robert, you might have to help me on this one. Can you explain what the Lenaro Linux image is based upon and how that works?
I might take this.
Yeah, there you go, Dan.
Well,
yeah.
Very early days on the Dragon Board 410C, we produced Ubuntu images. I think that's when Canonical was still a member. And once the trademark was out of access for us, we switched over to using Debian images. So the most fundamental difference between our current set of images is that our current set of images are Debian based and are traditional depackage operating systems. I mean, you guys are using the same kernel, so the same level of hardware enablement will be there, modular maybe a couple of tiny hacks in things like alsolib to get the, there's a few small hardware customizations in the Debian user space, but by and large, the bulk of the hardware enablement is the kernel, and Ubuntu Core uses the same kernel. So hardware enablement should be very similar. The main difference is Debian and dpackage versus Ubuntu Core and snaps.
And snaps, right, exactly. So yeah, it's really just going to be snaps versus debs.
I mean, also I would just add, like, on a very high level, novice user would look at this and say, the Debian Linaro image has a desktop, right?
That's true.
Ubuntu Core is
a big difference.
All command line. So when you boot up your Debian Linaro image, you're basically you're a full-fledged desktop environment, right?
You're in a familiar environment, yeah.
You can also get the developer version of that, which is just a command line version of Linux, but in general it's a desktop, and so Snappy is more so a command line version that you access.
Yeah. Ubuntu Core is very focused on servers or the Internet of Things, headless devices. In fact, right out of the box, we covered this in another OpenHours episode. There's no local login, right? The only way to get in there is with an SSH key. So, there are definitely some differences in simply the usability and familiarity of it as well.
Yeah, I shared
That's a better answer than mine, Robert. You can tell I never plug in the HDMI, can't you?
So I shared the trilogy of links there. So it starts from the last one, and then the most recent text or message was the earliest one. So Ubuntu Core 101. Then Kyle Fazari, right here. Kyle talks about in the last episode about working ROS on your Dragon board, and then dives in a little bit more into Snapcraft. And then Ogra, one of the other episodes, Ogra talks about the SD card images and hardware enablement and all sorts of fun stuff. So you have like 3 full hours of Ubuntu Core stuff right there if you are interested. And while we have you here, Kyle, I don't know if you wanted to just kind of give a little plug on testing days.
Yeah, certainly. So we have Leo Arias and myself are the main hosts of this one. Let me pull up a link here. It happens on Fridays. The time changes depending on the guest we have, but we have someone come and talk about the open source projects they're working on and how to contribute, that type of thing. Our previous one, we talked to Adam Stokes about Conjure Up. So this was a server-based one, OpenStack, Kubernetes, that type of thing. And before that, we talked to System 76. So we've got some really interesting shows here, and these are all recorded on the Ubuntu channel. So here's a link.
There you go. So you have their wiki.
And that's a live show as well, so you can come and ask questions, etc.
Yeah, and while we're on that also, I would suggest joining the IRC channels. You can join our IRC channel at OpenHours. There's also the IRC channel, what is it, Ubuntu-on-air.
Yeah, that's the one we use for testing days.
Another one, which is Ubuntu Snappy.
Just Snappy, yeah.
Oh, yeah, just Snappy. And then
that's for Ubuntu Core.
And then of course 96Boards. So all those hashtags, get in all those channels and join in on the fun. Kyle, thank you so much for coming in here on that short notice. I appreciate it.
My pleasure. Thanks for pinging me.
Of course. So I'm gonna close this out now, everyone. Once again, thank you very much, everyone, for joining. Appreciate your participation. Appreciate your efforts in the community. Make sure you sign up on that Google form that I shared to get your community efforts logged here with us. And we look forward to seeing you next week. It's a surprise episode. Don't exactly have something set up just yet, but I promise you it will be fun. All right. Take care. See you next week.